Hey guys, here we are at the beginning of Chapter 8. We're going to be talking about translations, reflections, rotations, dilations, which is not something totally new. I know you've done some of this before. Go quick to the highlights. First thing, we got a translation, which is we're moving the object from here to here. A reflection, we're reflecting it on a line, so this is acting as the mirror. And we have a rotation, so we start here and we rotate it around a certain point. Usually the origin is where we're going to be using as our rotation point. So we could rotate it 90 degrees, 180, that kind of thing. And then we have an enlargement. And that's starting with the object here, making it bigger. So we're using our scale factor. So, moving on. Starting with translations. The big thing that you're going to see with this is this is pretty basic. We're starting with a translation of HK. So that means it's being transformed H and K. We start with this point X and we're adding H. So we move it from here to here. And then we're taking Y and we're going from here up to here. So the new coordinates, we're adding K. So Y plus K is the Y coordinate of my new point. And my X coordinate is X plus H, which gives me this point here. So, and it's always set up, this is our translation. It's always set up H, K, and H is always the horizontal, this way. K is always a vertical, up and down. Give you a quick idea. It even has a special name called the translation vector. So we're going to take our original point, 0, 0, our origin. We're going to call it O. Then we have 2, 3. 1, 2, 1, 2, 3. Pretty basic. That's A. And then I have negative 1 and 2 right here. And that's B. There's our original triangle. And all we're going to do now is transform it, translate it. I know, I'm running away. And we could do it the fancy way and go 0 plus 3 changes it and all this stuff. But we're going to go simple. We're just going to go, okay, 0, the origin. We're translating 3 and 2. So I go over 1, 2, 3, up 1, 2, new dot, that's the origin. And A goes over 1, 2, 3, up 2, there's A. B, 1, 2, 3, 1, 2, here, B, we'll call them primes. And that makes that line. And that's a basic transformation. Pretty straightforward, I hope. Next step is it gets a little bit more complicated. We're going to translate a line or a curve. So in this case, we're using a linear equation, so it's a line. And the information is, so we have our equation x, what are we using? 2x minus 3y equals 6. My new equation is going to be called 2x prime is going to use new line uses x prime and y prime. Maybe x prime equals x plus h. But I want to replace 8x. So I need to know what x is. So x is going to be equal to x prime minus h. And y is going to be the same thing. Y prime minus k. Just because our translation vector is yk, hk. Okay. So knowing this, I can come back here and I go, okay, so x is going to be equal to x prime minus negative 1, which is x equals x prime plus 1. Then I have y equals y prime minus 2. So I use this and this to get my new equation, my translation equation. So I sub into equation. So I'm going to sub this into the original equation because I now know what x is and I know what y is, and that's going to give me my new equation. So I have 2x prime plus 1 minus 3 y prime minus 2 equals 6. This gives me my translation equation then is 2x prime plus 2 minus 3y prime plus 6 equals 6. So I have 2x prime minus 3y prime, and it's equal to 6 minus 6 minus 2, negative 2. 2x prime minus 3y prime equals negative 2. So what happens now is this is the translated line. This is the original. So what do I know about the original? We have original, we're going to go way over here, original. I know that 2x minus 3y equals 6 has a slope of 2/3. And I know it has a point. I'm going to see if you guys can guess this. I'm going to let x equal 0. And then what that does, it tells me negative 3y will equal 6. Because if I sub 0 in here, it's gone, and I'm left with negative 3y equals 6, y equals negative 2. So that gives me a starting point for graphing. So I can look at my equation, 2x minus 3y. I know it has a slope of 2/3, and it has a point, 0, negative 2. So I go to the point 0, negative 2, which is right here, and I use my slope to get more points, up 2 over 3, up 2 over 3, up 2 over 3. I'm going to go down to back 3. So I get this line. This is my original. Now, translating it, you're going, well, how do we do that? Well, we can do that with our translation vector. And we can double check that. First thing, our new one, we still have a slope of 2/3. But now I'm going to let y equal 0. And what happens there is I have 2x prime equals negative 2, x prime equals negative 1. So that gives me a point start of 0, negative 1. No, I got that backwards. Negative 1 and 0. Negative 1 and 0. See, I can pick whatever point I want. I usually pick something equal to x, or something equal to 0. So here I chose y equal to 0 because I knew it was going to get rid of that, and negative 2 divided by 2 was going to give me a nice neat number. Over here I chose to let, either of them would work, but I chose to let x equal 0 because I knew 6 could be divided by negative 3. I could have let y equal 0 and 6 would have been divided by 2. Either one would have worked. So now, graphing my new line, I have a starting point of negative 1 and 0. And I have a slope of 2/3, so I go up 2 over 1, 2, 3. Up 2 over 3. Up 2, 3. Now, what's interesting about that is if you look at our translated this, right here, negative 1 and 2. We're going back 1, up 2. Back 1, up 2. Back 1, up 2. And it's working to give us our new line. So, and they end up parallel, which they should, because we're just translating the same line, moving it around. And that's it. Let's see what else we got. Reflections. And that, folks, is translations.